Hello again, welcome to yet another COPS talk from me, sorry. I will do my best. So yeah, still not a fancy name, but using a clever wordplay on COPS. This is COPS for Unreal. Sort of an iteration on what I showed earlier this week, but I guess a bit more technical in some sense. I will try to show a bit more, I guess, behind the scenes of what I've been building. Yeah, so my name is still Simon Verstraete, technical artist, infamous for giving Alex a handshake or something, apparently now. So thank you for that. So today topics, quickly showing you what I did previously in case you might have not seen it or missed it. I will also talk a bit about the tool I made, like circle deformation, how that was going. Also point generator tool, PBR exporting tool. Then about the last few topics are about the baker that I've made, showing like a little bit behind the scenes how that is set up, and also the PDG network for automating textures at a larger scale. So, first of all, previously at Copernicus. Here are a few demos that I've made in case you've missed it. I don't know if there's sound. Oh well. This was like a planetary table, but with set of planets, that's geometries. This is also in Unreal because I don't render in Karma. I mainly try to use Unreal. So this was a little demo. So this is like a quick speedrun of like me going through the network, animating the thing, texturing the thing, all just using Houdini, exporting to FBX files and importing into Unreal. And that was a little demo. I also made this panel that I've done with Copernicus and Houdini. Then also this stylized texturing that I did. Oh yeah, this was like a little demo showing off the tile pattern tool. So by just having like a very basic, simpler procedural setups, you can do fancy things like this, which you kind of expect to from like basic procedural texturing, switching inputs and so on. Then I did a little other demo where I'm like baking assets. So I had a few assets and I baked them, I textured them automatically. And this is what I also will, of course, be talking about later on, how some of that setup was done at scale. And so for my final demo was this scene. So this was an asset pack that I bought and I procedurally textured all the assets in the scene to have, for example, something like this. But again, later on in the slides, more on details about that. So that was a bit about what I've created, and I will break down some of the aspects or tooling behind this. So to start a bit simple, I guess, the first tool that I've made, or HDA that I've made, is called a circle deformation tool. So we take a simple input and then we sort of like squeeze it in like a circle shape. And if you think about this, it's just mainly UV deformation. So we're changing UV spaces or UV coordinates to like be more in a circle shape. I guess most people here are anyway familiar with like UV coordinates. So usually we have like a 0 to 1 range. And if you unwrap it, a model, we would put our unwraps in here in the 0 to 1 range and so on. And then this way is how we can have a texture mapped to a model. So basically we have two gradients, one from the top to the bottom and one from left to the right. So quite simple. But of course, if we go outside of our range, let's say from 0 to 2, then we start to tile textures. So usually in games, you want to, of course, have tileable textures, which is pretty common for like walls or floors or bigger shapes or bigger buildings. We just want to have tileable textures, so it's always important. But anyway, what about the circle deformation? So you can see that we're just going from like a simple gradient to top to bottom, for example. So all these 0 to 1 ranges is quite one axis or left and right axis. So circle deformation, we need to think now the gradients into a circle. So very simple, we can now have a gradient that goes like this. So we have our 0 to 1 now in sort of like a more circle radial formation. So that's one of our channels. And the other channels, or the V channel, could be like from the center to the corner. So the center is 0 and then the corner is 1. And then we can build very simple coordinates for circle kind of deformation with texturing. But now, how do we bring this now in Copernicus? So this is like, I guess, the theory behind this. By playing around with the ranges of 0 to 1. We can simply, for example, use the ramp nodes. So you can see I put them here on radial and on concentric. And these are like the two coordinates that we would need to have sort of like a circular shape. To combine this, we just use what is called the channel join. And then we can combine a new UV type of data as output. There is actually another way of doing this. There are many ways of doing this. I've watched a few tutorials and like people come up with like different ways, but I guess that's the beauty of Houdini, solving the same issue with like different approaches. You can, for example, use something which is here called the UV to polar coordinates, which will also give like this circular coordinates that we are looking for. So this is the same, I guess, output, but just like a different approach to it. So if we combine everything into Copernicus, very simple. So we have our UV coordinates. We used a UV sample, which can be used to have an image. In this case, I put a font down, I typed in Houdini, and now we have a nice circle Houdini logo. So very simple, nothing too fancy, just showing you how we can just deform shapes quite easily, again, with that gradient 0 to 1 range. And this, one advantage of using the ramps is, I guess, more artistic control. So here is a little video about me playing with the ramps. So again, the only thing we're doing is we're remapping that 0 to 1 range, and just the texture is like following, so I can squeeze and stretch it to exactly what I want it to be. So again, we're just playing around with that. So we can do like a bit more funky results like that. So again, very simple setup, but you can see the possibilities. Like there are only like 5 nodes over there. Like these are just basic Copernicus nodes, and we can just already like have very interesting shapes to play around with. So again, the more ideas you have about this UV coordinates, the more clever things you could do. So these are like sort of like a couple ways of doing this. But I was thinking, okay, what if we could leverage existing tool sets in Houdini? Is there something in Houdini already that does something like this, like a bending operation? So what I did as well, what you could do now is you can have a simple grid. That's your, for example, your base coordinates, and you can just bend it. So you just bend the whole grid into, for example, now a circle. And then we can sample with the rasterizer the UV coordinates or other coordinates from that geometry. And since the bend node is a default node in Houdini, we just have all the features already, like just, oh yeah, how much angle do I want? So in this case, let's say full circle. Or if we want other features like a twisting, so we can twist the shape. If you want a bit more funkier shapes, or here other like a taper or the offsetting. Like these are all features like built in the bend node, which the gradient setup, for example, didn't have. Like now all these, I guess, features come for free or without any additional work. We just have basically a circle with a bend node. So it's nothing super fancy, but already just using what's there in Houdini without having to figure out everything at like a Copernicus level. We can just sort of like share and sample the data back and forward. So that's sort of how I made a circle deform tool. So in this case, one of the approaches was to indeed have like a rasterizer, and then you sample the UV data from the bend node and put it in the UV sample image node to then fully stretch out everything. So that's roughly how I made this pattern that I also previously showed about in my other talk. And I think this is a little video as well. So you can see I can change the tiling very easily. I can also here then do some more stretching as well. So this will sort of like stretch the tile or the input tile in all kinds of directions. And this is then more the bend-like features. So you can see I'm doing a half circle or a part of the circle. So I don't necessarily have to do like a full circle operation. I can play around with that as well. We can also have the more fancier things like here, like an offset or like the twisting and tapering to make a bit more funkier shapes like so. So again, like these things are, if you think about it that way, like just simply bending a grid, it's not very technical. It's just very simple using Houdini modeling tool sets, right? And this again just got me further thinking about the only thing that I'm doing here is making something in geometry and sampling the UV data from the geometry. So you could leverage the same idea in like everything else. For example, what if you just simply draw a curve and then sample the curve and then use that to deform, like in this case, a text. So in this case, just simple draw curve, like this is how the background is. Just simply draw a curve. I usually like to resample it, and then I do a sweep node. And in the sweep node, you can enable compute UVs, and that's basically what we do. Just grab the UV data from that, and then you can just use it to then displace images or text or something like that. Very easy to do now. And the same idea here is, let's say we need to have a sort of type some fancy text in like a spherical movement. So what I did is I just simply place a sphere with some UV. I sample some of the UV coordinates, and I just use it like this to have a deformation in that sense. So quite simple, I guess, thinking, and we can have some nice results in case you like specifically want to design something like this with like text going in like a circle shape. And I can also here, I want to say that the Labs content library, if you're not familiar with this, they provided a bunch of examples about more Copernicus stuff as well. So definitely check it out if there's more interesting stuff you want to see. Just wanted to point it out in case this is just useful stuff to just have like a little demo in case you want to just grab some demos without having to figure out everything. So yeah. Then another tool that I would like to have was a point generator tool. This is in combination with a stamp point tool. So these two nodes work kind of together. So the point generator tool generates points where I would like to have an image, and the stamp point tool will then stamp a certain shape on each point. So in this case, I generate a circle of points, and I will put a square on each point. And you can see also the rotation is according to like the center. So they're all looking at the center. So the tool itself is, again, not super complicated. Most people here are like really good Houdini users. So this is basically just a simple circle, and we just like have a few controls. So the thing is that you stay now in Copernicus. Otherwise, you have to jump into a SOP layer and then figure out in the SOP context what the exact radius should be of your circle. But now I can just stay in Copernicus and just have it here. So it's more like a utility tool that just helps you a little bit getting to the result you might want to see. Because usually you want to stay in Copernicus and compare maybe textures to each other easily. So this is just a little tool that can help you with a few things. So we can also make something like this, like a circle with like random scale on top of it, very basic stuff. And the way this all works is, again, nothing too complex. So we can have a circle, we can then do a resample, and then we can calculate the rotation by orient along curve, which is a built-in node in Houdini. And as you can see, it will calculate automatically like normals, or you can also enable orient attribute in case you want to use orient. So that's basically what I sent to Copernicus, to the stamp point tool. It's just a bunch of points with the attribute for the rotation on top of it. And then we have, again, these cubes, but you can also add scale and so on. So that's why I wanted to grab a snippet from the documentation. So if you're already familiar with like instancing and other types of data which would need, like the basic attributes are like orient, transform, normal, p-scale, vectors, up, and so on. Like all these basic attributes are recognized by the stamp point tool. So there's nothing new in here. It's like quite straightforward if you already know how some of the elements in Houdini work. And then I sort of like did an iteration on it. So what if we can, instead of having a circle, you can see I'm also having like a scattering setup. What if I just simply place a grid and scatter random points by using the scatter tools in Houdini? So I can create, for example, like this little noisy or scratchy details that you might want to apply on some procedural texturing. So that's how the network looks like. I have a grid, I have the scatter and align node, which is really cool. And then I've also used the labs instance attributes, which usually helps creating some basic attributes for your setups. So the output attributes are just your classic orient, p-scale, and scale. So these are the classic attributes for, I guess, instancing in this case as well. So that's how I just simply made a bunch of, like, I guess, random noises or random points on that for the stamp point tool. And this is also, I guess, a more practical example where I used it into. So this was the stylized material that I've made. And you can see some of like these dots here are done by this tool. So I generated, for example, something like this. So just random points with a random shape on top of this. And I used this to be subtracted at my original tile sample. So you can see the darker spots here and there. So I quite like the idea of this sort of like stylized denting or damages. And I would also like to have like a border around each them, like for a highlighting. So what I've did is I'm using the edge node or edge detection to create like a sort of like a border from my original pattern, which was this. So I'm just using edge detection on this, and I will have then these round edges. And I use this to like highlight the model. So you can see if I go quickly back and forward, you can see we're like sort of like highlighting these points here. So that's roughly how, I guess, a bit more practical example on what I've used with that tool as well to make a bit more, in this case, quite stylized approach. And this is sort of like the end material that I made. Again, quite simple, stylized procedural texturing. Then, PBR exporting. So usually for games, you want to have like PBR exporting, PBR textures. I guess most people are familiar with what PBR is, like physically based rendering. It's what modern engines use to render materials and so on. So basically for each material or asset, we would have things like a metal roughness workflow. So we have a roughness map or a metal map, or we have also spec gloss workflow, but most people use metal roughness. So usually we want to have like a bunch of textures automatically or exported, and in Real or other game engines, we would then use them to make our materials. So I made this little tool that sort of like uses the preview material node as input and exports the data that you plug into. So in this case, I have base color, roughness, normal map, and height. So it will automatically export some of these textures, so I don't have to like manually export it one by one and so on. Maybe there is a better way, but I just made my, I guess, utility node to do some of the exporting. You can also see I automatically target a base name and a directory, so I can automatically have called something material underscore color. So I will automatically add the naming to the right location. Now, the way how this works is not complex at all. The first thing that I did is I looked at how the material preview node was built. So it's built like this. You can see just a bunch of null nodes that have the correct name, like base color, roughness, metal, like all these nodes are just in the material preview node. So the only thing I need to do is just make a dynamic path, grabbing the material preview and then copy pasting a name like base color. And then from there I can easily grab some of the textures. So that's what I did. So here's a little snippet of that. So you can see that I'm typing a dynamic path, grabbing the material preview node, which was an input from my HDA, and then I manually type in /base color, which is then of course referencing to my base color. And that's how I roughly can export some of this. This was quite rough, but it used to work, it works for just very simple things. Ideally, we would like to also maybe like pack textures together. In games, you like to like pack textures together to be less textures is always better. So in this case, it doesn't fully support all of these things, but this was just a little handy thing for me to like quickly export something. Just place the nodes, click export, and all the textures are exported in the folder where I want it to be. Now let's go over maybe something more interesting, which is the baker. So I wanted to create a baker inside of Copernicus. In games, you often bake things. So quick example of that. So this is an axe that I've made a while ago. But of course, polygon-wise, we cannot have an infinite amount of polygons. So we need to create something, what we call the low poly, and then we bake the details from a high poly mesh into a low poly mesh using textures like your normal map and other maps and so on. So that's mainly what we do with game engines, trying to have a low poly model and bake all the details into that model. And here is again another example. Let's say I have a cube that's very noisy and has a lot of surface detail, and we're just going to, for example, bake a normal map on a very simple model. So again, modern game engines can of course afford a lot of more triangles, or like with Unreal 5 and Nanite. But like if you still would make like a mobile game, or maybe a web game or something, you want to have like very low poly models. So this is where baking has been used for decades now in games to make very cheap geometries. So things that I'm going to further talk about are actually more also related directly to a talk that Paul Ambrosen did. So this is from his Labs Maps Baker that he originally started a couple of years ago. He's also here, so if you have questions, go to Paul. Don't go to me. Or you can come to me, I will ask Paul and I'll get back to you. But yeah, so originally, if you want to have more details, I heavily recommend you going into his talk. This is 35 minutes of him going in a bit more detail on a variety of things. I will sort of like give you a 10-minute version of this. So I will definitely need to skip a couple details because I cannot go into every single part of it. So you will see that in a moment. And also partially what I wanted to do is compare the old cops to the new cops in a few ways. So you can see what sort of like has changed and how easier it is now to get some of the data for baking, for example. So if you've not used the Labs Maker before, it's quite fast and simple. So you have your low poly model and you have a high poly model, and then you have in the node a button that's called bake, and then we bake things like your normal map or other maps you want to use. So overall, it's a pretty cool tool and it does what it needs to do, export normal maps or other textures from a model. So some of you might already use it and be familiar with this, but of course it's still now currently using the old COPS setup. So by that, it's also automatically a bit slower because it's relying on all that older tech. So here is a screenshot of what the Maps Baker looks like. So one thing that you can notice is that they use a lot of nodes, which is called the VOP cop, which is just simply saying we want to code something instead of placing nodes. So all of these nodes are almost like coding or VEX inside. So that's how it was originally done. So a lot of coding, a lot of pressure, I guess, on like having knowledge about VEX and understanding how to code some of these elements. So with the new stuff, it's changed a little bit, I guess. So this is what my version looks like. Again, I put in very large letters. This is a prototype. This is not final or anything. This is just simply for, I guess, more this presentation or demo that I've specifically built this in like a few days. So you can see my network is pretty small. I don't have all the features that the Labs Baker has, but I have like very simple features like your classic normal map, ambient occlusion, curvature, and a few other tricks that I could do. So you can see the difference already like in the network and structures. Mine is a bit more simple, but of course, if you want to make this in production, it probably expand on additional functionality that you probably want to include. I can also show you a demo here that I have, a little video. I call it Asset Baker, not to be confused with the Maps Baker. You can also call it Copernicus Baker. I don't know, too many names for the same thing. So not to be confused with other bakers, right? So this is here in action. This is live in real time on my computer at home. So you can see it works pretty fast, like capturing some of the normal. So this is just, if you want to build this, I would say start with the plane with a sphere or something. Start something simple, and then just capture the data. In this case, just like a simple normal map. So this was some early exploration on just trying to get the data into a texture with Copernicus. Then I did did a few more iterations, and of course I added a few more assets in my scene. So this is a asset from the asset pack. So I do procedural texturing, but next to it I also do the procedural normal mapping, or automatically bake the normal maps and curvatures. So that's what you see. It's a little video. So I will swap to a different asset, and you will see in a few seconds later, I will now have the bakes and the procedural texturing. So this is all again in real time, not speed up. So in a few seconds, we're literally just baking the models and texturing the models, all done in Copernicus with this tool set now. So you can see it's quite fast, and you can get some nice results. Again, I went for a very stylized output, as you can see. Now, okay, a bit more details on how this was built. Step number one for this baker is getting your data from low poly, for example. So preparing the data. And the way that we can do now is simply using some of the rasterizer or UV sample toolset. So here, what we can do is our very classic setup to get the data from geometry now, sub import, rasterize setup, and then the actual rasterizer to get the attributes. So you can see I get the rest, which is basically position. Then I get the normal, then I get the tangent. So this is what I extract from the low poly model. Then, yeah, this is basically what it would look like if you would preview it in your viewport. So I'm basically saying that my color is equal to my position, and we have something that looks like this. So if I put that next to my texture, you can see that we now have exactly the same values. So of course, Copernicus can go outside of 0 to 1 range, and sometimes it might not be visible, but it will just capture, for example, the position data in a texture. So later on what we will do is we will use the position and the normal to find out if something is in front of us, to do a sort of like intersection test for against the high poly. Yeah, a few notes behind this. So the rest node is position, the normal is for the normal, and then the polyframe is for the tangent. So that's basically what you can do as well. Now comparing it back to the current, to the old COPS node, this is how the Maps Baker does it. Just a bunch of code. So they're using a function called UV sample. So if you wanted to do something simple before, you had to use the functions called UV sample. But nowadays we can do this without any coding, just these nodes. So in that case, I guess it makes it a bit more friendly for most people without having to worry about like making a bunch of code to actually get some of the data. So I guess that would be a really good thing now that people are more interested in grabbing data from geometries now. Okay, now go to step number 2, which is getting the raycasting or intersection from the high to low poly model. Before I go into it, I quickly wanted to show you that there is now a nice Wrangle in Copernicus. So if you're already familiar with Wrangles and Vex, we can now just simply do the same. So the only thing special here is the way how we input something is we just go to the multi-parameter, we define our type, so in this case mono, so a float, and then we give it a name like data. And then we just simply say add data multiply by 5. So that's how we can create, I guess, our own image processing setup. So you can see it's very easy to now make an if statement or do a bunch of loops or something like that. It's basically Vex. Like if you're familiar with Vex, you know exactly what you can do with this. So you can just plug in textures, give it a name, and then just run the data on top of this by just using our classic add data and whatever. So the way you can think about this is in geometry, we would often loop over points or primitives, but in this case, we're looping over pixels. So we're looping over each pixel and we do a certain operation for each pixel on the texture now. So that's how, I guess, you can see the Wrangle in Copernicus. So you can do a lot of like now custom processing with just simple Vex code if you want to. And that's exactly what I did. So I used here the function called intersection all, which gets intersection along the way based on the distance you provide it to. So we're getting the position from our low poly, and then we're getting the normal. So we're again trying to look how far it goes. I actually brought a little, I guess, like easier snippets. So let's say our low poly is just a simple plane, and my high poly is the sphere, like in one of the videos that I showed. So the only thing we're doing is we're using the normal of the mesh to look forward in us. And we're trying to see if we are hitting something. Like in this case, my high poly is in front of me. Like, are we hitting something? That's what the intersection function is. Are we hitting something? And of course we are, because intersection all will give all the points where we hit something. So in this case, we have a few hits. And what we get from this data is we get the position, the primitive number, and the primitive UV coordinates. So this is the base data that I would like to have from this stage, like a simple intersection, getting the data out there, so we roughly know exactly what to do with the data in our high poly model. Then step number 3, for example, could be extracting the world normal. So we can now use the data that we had from this intersection to sample or get more data from the high poly as well. So as you can see here, we can simply say like, hey, I would like to look at the high poly model. I have the primitive number and the primitive UV. Give me back the normal of that location where the original intersection was happening. So you can basically see it like this. So we have all the intersection points, and we're just basically asking like, hey, give me the normal of this mesh. So that's the way we can sort of like extract or bake the normal of the high poly mesh into the low poly by just using some of these setups. We are getting some data already working, like not much code actually has been written. I showed you some of the code I've used. It's not, of course, perfect, but you can see only a few lines of codes were needed to make like some simple baking. But step number 4 is getting more of your final maps, like here. Okay, what are the maps I want to export? In this case, here are a few examples. So this is a normal AO and curvature. You can see some of the code behind this. But in reality, what I actually did, because I was also running out of time, is I just started to look at how the maps baker does it. Because some of the thinking and the code is all VEX, so you can basically share the code. There is still a difference between, I guess, the old COPS setups. So you cannot just simply copy paste the code. There is still like a few parameters and a few functions you need to change, but in generally, it was quite straightforward to just use the same logic and thinking and apply it in the new Copernicus toolset. So if you already have a lot of like old COPS tools, it should be relatively easy to maybe implement in some of the newer Copernicus networks. I was planning a live demo, but maybe we're running out of time. So I will just skip it, and you just have to believe me, everything works and so on. Yeah, so the last thing I want to talk about is PDG. I guess most of you are familiar with PDG. In case you're not, it's just basically about a tool set in Houdini that allows you to automate a lot of tasks, like, I guess, processing a lot of textures, for example. So, of course, Copernicus works now with this. So I used this asset pack that I had, and I wanted to do a procedural texturing on all the assets that are provided from the asset pack. So here are some images from that. So this was like, again, my first setup. So this is a few assets that are automatically textured in Copernicus. And then I did the whole scene fully textured, again, using Houdini and Copernicus. Now, the way how this was set up, in case you want to have some more context on how this was created. So what I like to do, first of all, is just have a geometry node where I just do my setup once, like a very simple import of an FBX file, baking my thing and texturing my thing, and then have something that looks like this. And for example, I'm happy with this. Then I will place a top network here next to it. And in here, what I will do is use the file pattern node. This node can automatically grab files from locations. So in this case, I say, look at this folder and grab all the FBX files. I like to start with a smaller amount of data, like 9 different FBX files, and then later on, of course, scale it up to a higher amount. So now, how do we link this node in the geometry network? Is I can simply use add directory, add file name. If you're familiar with PDG, you know exactly what this is. So we're just grabbing that PDG attribute inside of the file node. So we're now linking PDG with my geometry setup by this file node. So that's sort of setup. So we just need to have the padding with the values and the expressions. And what we now do is outputting. So the ROP fetch node will basically be a node for outputting your data. So in this case, I have for textures and for FBX file. So we're literally just pointing to my Copernicus network, which has a ROP image. And this is then outputting or exporting the stylized texture for my scene. And also similar for the FBX file, I'm just pointing to my FBX file that I have in my geometry network. And I'm just basically saying like, hey, every time we have something that's generated, click a new export FBX file. In this case, I exported multiple FBX files to have like nice before and afters in the final scene, because the original assets were having different textures for the stylized approach. So I basically did some auto UVing to match my textures. And again, yeah, here is how we can, again, link some stuff in PDG. So if we export something, we use the add file name, which is again referencing to the original file pattern nodes. So the original file name will basically be used now for the final output as well with the add file name expression. And this is how the final setup could look like. So I'm only using 3 nodes in PDG, so don't think PDG is super complex if you want to do simple things. Like we can just here scan all the files. So in this case, file pattern is getting 270 assets on my disk. Then I'm telling it to be exporting all the textures, and then I'm going to say export all the FBX files. And that's sort of the, I guess, the loop or the process. So very simple. If you want to get started with PDG, build something like this, like something super simple and straightforward. Generate models, export models, and try to get wrap your head around how that works. And then from there, maybe build a bit more complex structures. And that's sort of, again, what the final output could look like. This is, again, one of my first early tests once I have a few assets working. But then I was still wondering, and I also talked about this before, I have 270 assets in my scene in Houdini, or that is now, I have 270 textures. So how can we now bring that all inside of Unreal in a bit more automated way? And that's why I used a little bit of Python to sort of like fill in the gap or fill in the bridge between having a bunch of data coming from Houdini and transferring that into Unreal and link up all the data. So I'm not necessarily going into very detailed scripts, but I will just show you the general thinking because it's not necessarily super complex. So script number 1 is basically, I guess, more of the setup script. So setting up your assets in Unreal. So for each FBX file, what we want to do is create a material in Unreal. So we just call the Unreal API to basically say, make a material. So we will just then create materials. But of course, we don't want to create new materials. We want to create instance materials. So of course, if you work with Unreal, you want to create always instances of your master material. So you can always have your base material and then some other instances of that. So that's basically what I do. So I call the function to create a material instance from my main material. And then we also need to see if we need to import a texture and assign the texture with the material. So I'm making material and set the texture on the material. And then the only thing left is to then also apply the material into a static mesh. So we're having a static mesh in the content browser with a nice material and the textures on top of it. So this is a little script that just does the setup. So as you can see, it's not complicated, but it does the main setup of like setting up all the assets. Then script number 2 is what I call the swapping script. So we basically have a scene from the asset pack. So the asset pack that I had, they had a few little scenes that I could use. And I was thinking, what if I can now swap all the assets in that asset pack? So I don't have to manually like go over all the, I don't know, 500 assets or thousands of assets. So again, a little simple script in Python that basically looks at your scene that you have open, gets all the assets or static meshes, and then basically I point to a folder where I have my new assets, and basically if the naming, based on the naming, I will just say like, is there a new asset available in my folder? If so, then we just do a swap between a new asset from my newly baked textures. And that way we have then a new scene. So that's roughly, I guess, script number 2. And then this is a little video about this. So the PG Copernicus, a little demo. So here, this is the original scene. This is a first texturing scene with highlighting of edges, and this is then a stylized variation with darkening the edges. So again, everything is like fully procedural in some way. I didn't know beforehand how it's exactly going to look like because I'm just automating everything. And there are, like I said, 270 assets, so I never can predict what every asset will look like. But in this case, most of the results were, as you can see, quite stable, not many issues or artifacts. So you can see it did a good job to have some like procedural texturing going on in this setup, as you can see. Yeah, so these are like, I guess, side by side. So I have now 3 different versions of the scene. In theory, I can even easily make more because I have the whole pipeline set up, so I can easily add more. So this is the original one, like I mentioned. This is what you would get if you would have the asset pack, a simple stylized low poly asset pack. But if you want to make it a bit more unique, let's say we want to have some more artistic control, we're going to then, for example, use Copernicus to procedurally texture everything in one go. And everything is nicely contained in Houdini, as I showed you with PDG and all these texturing and baking setup. It's all nicely done in Copernicus. And again, once I figured out how I did the base pipeline, how I did the base structures, I then easily could make a variation on top of this and create a third or a fourth one. It's very easy now to just make more variations because it's just more, I guess, artistic choice of figuring out the look. So one thing you can see here is I try to do something with circles. So a lot of the assets have like circular shapes. So I just have an asset and I spawn some circles and scale them every time differently based on the asset. And that way I just have like random circles. I thought it would be funny, and maybe I do another iteration where it's maybe other different patterns, maybe some bit more cooler patterns. So there's a lot of things we can do now here. Like again, I have the base pipeline working, and now it's a bit more, I guess, artistic choice of what I actually want as visual quality. I guess now to finish off a little bit is, what about some of the details of how long this took? This took about 30 minutes to reprocess a whole level. And this is even using basic PDG settings. I have not touched a single value. Like if you know PDG by default, it's pretty safe values. It uses like 4 cores. So you can easily crank this up to use more of your PC hardware or use a PDG session to speed it up. So I guess in theory, if I would play around with PDG, I can crunch the 30 minutes down to maybe, I guess, under 10 minutes, depending on, I guess, your hardware again. So it's possible that we can easily crunch this down to faster amounts. So again, I guess the only thing left is now actually figuring out the art style, sitting together with your art director and being like, okay, what do we want? And then like 30 minutes later, it's like, okay, here's the new result. So the most of the time is still spent figuring out like, okay, do we have a highlighting edges or do we darken it? Do we have gradients? Do we have scratches? How stylized do we go? So it becomes a very like iterative process, and we can easily rebuild a lot of the things here. And that's roughly where I'm going to end my talk, because I'm thinking I'm running out of time as well. Okay, here it is. Thank you.